Doug Schaufler of Penn State University is our presenter today. Doug is an engineer with a background in the equipment industry, having worked as a design engineer at Caterpillar Tractor and for Stolz Fluid Power in central and northern Maine. His introduction to agricultural safety began with the Agribility Project in Pennsylvania, serving farmers and farm family members affected by disability. For over 20 years, he has been involved with Penn State Agricultural Safety and Health Team in various capacities, most recently working with us at the New Bio Project, focusing on the hazards associated with the growing and processing of biomass crops that may be different than those seen in conventional agricultural operations. So today, Doug is helping us fill that knowledge gap in the industry, and we're very lucky to have him with us. Doug, it's all yours.
Okay, thanks very much, Sarah. I appreciate that introduction. And welcome you all to the webinar today. And as Sarah said, if you have any questions, please type them into the chat pod and we'll get to them at the end, or if I can keep up with it, I'll try to get to them as we're going through if it's pertinent to that particular time. First, I wanted to just take a look at general overview of the so-called New Bio project that stands for the Northeast Woody Warm Season Biomass Consortium. And you'll note that there are many different areas within this project, some that deal with specific biomass crops, especially the three that this project is targeting, the willow, switchgrass, and miscanthus, and then also an area of how to best move that product from harvest through storage, and then also how to reduce that product, the biomass product, to a final useful product for the marketplace. You see safety and health there circled in yellow is kind of one of the umbrella pieces that has an overview of many of the different areas. Our focus, though, has been primarily on the production, the growing of the biomass, and also some of the small-scale processing facilities that are turning that raw product into something that is actually the marketed product. The goal for our particular area, the safety and health area, covers these four different places. One is to try to take a look at what the hazard and risk exposures are for the growing of the biomass and how those may differ from traditional commodity crops such as wheat, corn, soybeans, typical crops that farmers are growing on a regular basis. And second thing on there is how do we apply then some of the tools that are used for safety management, risk assessment, safety assessment to those biomass production places to develop some education and training materials that are pertinent to biomass. And then bottom line is to limit the damage caused by unwanted events or incidences within that biomass industry as it matures and grows in the United States. So the two things we're going to be looking at today primarily are something that we've pulled together over the last few years to try and apply some of these tools and put them into a package that somebody can use who either is starting a biomass industry or is changing over to growing biomass rather than traditional crops. Some of those tools that can be used to plan safety into the kind of the umbrella, the working management of the company itself or the farm itself. Oftentimes, safety and health is just interpreted to mean, well, you got to wear your personal protective equipment, work safely, make sure all the guards are in place. If you see something that's broken, do something about it, get it fixed, and whatnot. But it really means a lot more than that. It means trying to take the safety and health culture and make it a part of the workplace. And so you're creating an attitude that really integrates safety, not just at the worker level, but also at the management level and everywhere in between. Supervisors that are between management and workers, and that everyone then has a part in the safety culture that's developed within the company or within a farm. It can be a small farm or a larger company. Either way, so that it permeates the entire fabric of the management style and scheme. So the primary reason for the safety and health is to reduce workplace injuries and fatalities. At the end of the day, everyone wants to go home safe and wants everyone else in the workplace to go home the same way. There are, in today's world, other reasons for promoting the safety and health issues. One is that insurance companies may require someone to have a safety plan in place, or may require monthly safety committee meetings as a documented way of showing the company's sincerity about safety in the workplace. Then the other one is, with liability or lawsuits being what they are oftentimes, a documented safety plan and continuing safety program is evidence that you are committed to safety and that your company is doing something in the safety realm, and it may reduce liability in the long run should there be some sort of a lawsuit. But behind all this, we talk about saying, okay, let's move safety and health management into kind of the higher levels of a company scheme or a farm business. Well, when you're going through school, whether it be for an undergraduate degree or for high school agricultural program, the safety message that you get is generally targeted toward working safely and reducing hazards and just real specific things that you can do to be safer, how to lift properly, and those kinds of things. But it doesn't really ever talk about how safety and health can become integrated into the actual management plan of the operation. So we've pulled together information that Dennis Murphy has gathered for years on agricultural safety and health issues, and just pulled together a lot of the things that work and tried to make it into a reasonable size publication that targets safety and health management planning for biomass producers. So the ideas contained in this publication will be for small farms, those who are growing maybe a couple hundred, 400 or 500 acres of biomass or less or more, up to companies that are processing biomass or taking in biomass from thousands of acres and are making that into a final product that then is sold into the market. So this is the publication I want to take a look at today. Just some of the things that are in it, not all by a long shot, but some of the things that are included, just to give you an idea of the sort of range of what's in here, and of course to make you want to delve deeper after the webinar is over and in the coming months, and how you can apply that then to your operation, some of those ideas that are present. So what's inside? There are 5 different units that are presented here, about 60 pages overall, so it's not too daunting a manual. A little bit of light reading here and there can get you a long way, and goes through, and this is what we're going to be taking a look at today, just each one of these units, establishing safety policies and procedures within a company or small farm. Second unit's on identifying and assessing the hazards and risks that are there and some of the different ways that you may not be familiar with of doing that. Third unit's looking at preventing and controlling hazards and risks. Okay, we've looked at them, we figured out what they are, or some of them anyways, and now we want to figure out how we can mitigate those hazards and those risks. The fourth one, how do we educate and train employees? And then finally, how do we take a look at if our training is being effective? Are we actually getting the message across that we think we are, or that we want to be getting across? So those are the different areas we're going to be taking a look at. We'll get going with the first one there, establishing a safety policy. And this, though lacking in many places, is really the foundation that everything else is built on, because it's taking the time within management, but also including workers at all levels, of what part should safety play within the company, and how are you going to get there? Whose responsibility are the different things going to be? And it's important to realize that anything that's put down here, and it should be put down on paper, it's a written document, but it also needs to be realized that it applies to everyone: the workers, the managers, owners, family members, visitors, customers, anyone who comes onto the property or is associated with that company, it affects all of them. And so one of the things that has to be decided is who's responsible for what within the structure of the company or within the structure of the farm. It may be the operator, manager, the workers. Here we listed out the supervisor, crew managers, and different responsibilities they may have. You just need to realize that anything in this manual is an example, and it certainly can be adapted for anybody's particular situation. One of the things in here is, how do you get workers involved and enthusiastic about including safety in the management scheme? For one thing, having management approaching workers and saying, hey, safety is important to us, you are important to us, and we need your involvement in this because you are the people on the floor, you're the people dealing with this all the time, and we need to know what it is that you need so that we can all be safe in our jobs and we can all do the best job we possibly can. So there is a portion in here that's devoted to how to get workers involved and enthusiastic. And I have been to some safety committee meetings that are just that way, that there really is an entire belief that this is so important that, it really is, it's almost infectious to be there because people are looking for things. They're looking at the suggestions coming in through the suggestion box. They're really believing that what they are doing can make a difference, and the workers believe they're being listened to. So the written document, there are a couple examples in the manual, one for a larger company structure and one for maybe a smaller farm type structure, family farm, but they each have the same sort of an area and the same sort of things called out. So first thing is just saying, yeah, we're committed to being a safe operation. Second one, set specific goals and how we're going to get there. Third one is, who is responsible? We just mentioned that different people have different responsibilities in bringing this safety culture together and all working together toward that. And then the last one is rules that apply to everyone. And that everyone is very important in there. If the owner of the company comes out on the shop floor and doesn't have safety glasses on, then that sends the message to everyone, obviously, that that's not important. And so it just has to be something that truly is followed through with by everyone. An example is one of the best ways of setting that. Another piece of this safety policy would be, how are new employees going to be trained in the ways of the company and the ways that are expected, or the things they're expected to do and the ways they're expected to perform their particular job within the company. Research shows that new workers are more likely to be injured than experienced workers. And so this training part is very important. And it needs to be, again, a documented sort of thing that the company up front says how they're going to do it and then does it that way. So that's setting the foundation. That's setting the groundwork for the company, saying this is what's important to us, safety is important. And then we need to go on then and say, okay, how are we going to find the things that we need to be concerned about within our operational scheme, with the way we do things? And so within the manual, there are a number of different ways suggested to do that. I'm just going to take a look at a few of those here today. Very simply is kind of an overview, sort of a checklist way of looking at things, a very simple way of getting going with things. Yes or no, maybe once a month, somebody, the supervisor or a worker within a certain unit area of the company, goes around and looks at things and checks off yes or no, or this doesn't apply to us. Somewhat useful in just saying, yeah, there are some hazards here. But you may find that there's some other information you want to be keeping track of, so you can expand the checklist, as shown here, where we've added a column for priority and a column for target date. Some things are going to be like, yeah, we got to get that fixed right away, and it better be fixed by, the beginning of work tomorrow. And so that ought to be noted on something, and then somebody needs to be assigned to be taking care of those things so that these things actually matter and move forward. So idea of a simple checklist and then maybe an expanded checklist. Both are things that can certainly find hazards, keep track of things, track how action is being taken on fixing things. But we also all know that hazards don't exist just in a yes-no category. So there are some other types of, or other methods of looking at hazards and giving them some sort of a rank besides just yes or no. If you take a look at the slow-moving vehicle emblem, or SMV emblem, in the bottom left corner of this slide, you can see that it's bent. If you know what a SMV emblem looks like, it's usually a brighter orange than this one is. So this one's been on a piece of equipment for a number of years and it's faded out, but it is there. So you can't, so if you were doing the checklist as a yes-no sort of a thing, would you say yes, it's there, or would you say no, it's not quite good enough? It kind of falls in the middle. So some of these other ways of ranking hazards allow that sort of a Likert scale, that yeah, it's there, but it's not as good as it could be. So this one is called Farm Hat, and that stands for Farm Agriculture Rural Management Hazard Analysis. Task sheet, test. I never can remember the T. But anyhow, it's in another slide or two. But it gives you a way of looking at a hazard, saying, yes, it's present. You know, this is pretty good, but not as good as it could be. So it gives you a way of ranking the hazard as well as just saying yes or no, it's present. Then when you take a look at the hazard audit results, again, if something offers, here 1 is shown as most protection, 5 is least protection, and the hazard level is negligible or low, moderate, severe, or high. And the corrective actions then can kind of mirror how severe or how much protection is offered and how soon that ought to be fixed. And so instead of just saying yes or no and you end up with a list of yeses and nos, you can kind of rank things as things that should be taken care of first, things that maybe can be put off a little while but ought to get fixed, and then things that ought to get fixed over time but maybe not be too concerned about at the moment. This Farm Hat right now is available as a web-based audit tool. You can download the portions you want of it. It's approximately 160 or so different hazards that exist on agricultural operations, both in buildings and outside, on machinery, fencing, all kinds of different applications. And then also we're working on putting this together. This is something that was put together at Penn State, and it is also being worked on as being put together as a app that would be available for an iPad. At least that's the first platform for it, is the iPad platform. And that way it would make it more accessible and easier to use as a hazard assessment tool on farm or in a plant production facility. That brings up something else, and that is that in this manual, many times hazards and risks are just spoken of as the same thing. And in this manual, it differentiates between the two, where the hazard is something that exists or can exist that can result in injury, illness, death, or other loss. And a risk is something different than that. It's more of a probability and severity of possible harm. And so it's a combination of those two. It's a rating of the probability of something happening with a rating of how severe are the consequences of that if it were to happen. So it's a combination of those two things. So hazards and risks, often spoken of as the same thing, really aren't. There's a bit of a difference between the two of them. The risk matrix is a way of looking at the idea of risk, where you have the consequence here across the top row and the frequency in the left-hand column. And it just gives kind of a visual way of taking a particular situation, a particular hazard, and putting it into one of these categories of, if something's fairly negligible and very unlikely to happen, well, maybe you don't really need to worry about it too much. As opposed to something that might happen a lot of times and have a pretty critical disability or very high bad injury associated with it. And that might fit up toward the left-hand corner where the red printing is. And we ought to really just shut down until that's taken care of. So to take and kind of make a risk matrix for perhaps a biomass operation might look something like this, where somebody cuts their finger. Yeah, it's not something you want to have happen, and you certainly want to take steps to mitigate that so it doesn't happen. But it's not going to be a life-threatening thing. It's not going to be something that sends someone to the hospital. Probably isn't going to kill them. So maybe it isn't all that big a thing to worry about. As opposed to if you've got a tractor overturn because you've got a tractor without a ROPS that's still on your operation and being used. Well, those things do happen occasionally, and usually the injury is pretty catastrophic. It's either death, permanent disability, or certainly within the realm of reason for that sort of an incident. So it gives a way of looking at different scenarios and kind of making this risk matrix that kind of lets you know what things you really should be concerned about and what things can maybe wait till later. And once you got the big ones taken care of, then you can start kind of working your way down through. But it gives you a way of prioritizing your hazards and figuring out kind of a logical way of working your way through them. So that's about looking at hazard, looking at risk is the second part of this. And then the third comes up to, okay, we've started seeing some of these, or we've identified some hazards where we're thinking about what the risks are of those different hazards. And we've got those kind of figured out what they are. Now how are we going to work through mitigating those, making this a safer workplace? There are 4 principles for preventing and controlling hazards. We're going to take a look at those as we work our way through here as well. The principles that are here, first one is that an incident that causes injury usually has a bunch of different causes, not just a single cause. And there's something called the Hayden matrix that allows you to look across the spectrum of things and break it into different categories. One might be the category of the workers. One might be the materials you actually use to carry out that job, the equipment, products, and structures the buildings are housed in. And then another might be the physical environment that you're working in itself. And then down the left-hand column, it's got chopped off, but here it's called phases, and there are 3 of them. One is things that might happen before the incident occurs. One is the incident itself, so the event itself as it's happening. And then one is post-event, the things that happen after the event. So some of the things you might be thinking about, they don't necessarily read across as a row, but they're just different things that fit into the different categories. So under the workers category, it's kind of the things that are being looked at that help the workers out. A safety and health management plan for biomass operations. If there's a plan in place and a policy, if there's training that takes place, all of those are things that would happen before an incident occurred and are things that could be a factor in an incident when it does occur. If you look at the equipment, products, and structures part, you look, before something would happen, you'd want people to be using the properly sized equipment. You might have heat detection and sensor systems in place to watch for fire or hot spots as they're developing. Using the proper things for hauling materials. And then the physical environment. What sort of place are people working in, or is this work taking place in? Is there shade and water during the hot weather? Are there heaters and shelter for cold weather activities? And so the Hayden matrix goes on to look at these not just for the pre-event, but also for if an incident happens, what's happening exactly at the time of the event, and then after the event, what sorts of things are in place to support things that need to be done after something has occurred, or ideas that maybe should be carried out so that doesn't happen again. That's called the Hayden matrix, and again, there's more complete information on this in the manual itself. you're interested in looking at that further. The second principle just says that injury prevention isn't always dependent on just the exact thing that happened. So look beyond the direct cause of the incident for things that might to find effective preventions that might not have anything to do with the direct cause. And this is just a real simple example, but sidewalks aren't supposed to have more than an inch of, maybe it's half an inch. Anyhow, they're not supposed to have a big overlap or a big piece sticking up where somebody can trip over it. It doesn't take much to trip over it. So municipalities are having people, if they are responsible for the sidewalk in front of their house, mill that down so that there's no trip point. Well, the easy thing is to say, well, just watch where you're walking. Don't trip over that. But that isn't necessarily, and that would be one way to solve the problem, but people will still trip over it if it's there. So taking care of that, milling that concrete down to make it less of a hazard, takes away the hazard. So don't just assume, I guess, that if you say, hey, don't do that, if there's a way to take away the hazard, to make it not happen at all, that's the better way of approaching that. Third principle is that you can't depend on people to do what makes sense. That goes for safety decisions as well as other decisions. That's why here we see fuses. You use a fuse box because the fuse box protects people from plugging too much into a circuit. And people should know they can't plug too much into a circuit, but they would anyway, so something there that they don't have to do anything about takes care of that problem for them. So this idea of passive strategies, things that are done without anything having to be done by the participant, are obviously better ways to go and will provide more protection in the long run. Principle 4 is that there is a hierarchy of control for preventing and controlling injury, and this just gives a way to really think about, either for a safety committee or an owner, manager, supervisor, or an employee, to think about what are the different ways that we can mitigate hazards. And it just shows that the large part of the triangle up at the top, it's just pointing out that, these are the things that are the best ways of controlling. The least effective ways of controlling come down here to the apex of the triangle, down here on the bottom. So top is best, bottom is effective, but not nearly as effective as the ways listed nearer the top. So we're going to take a look at each one of these, and an example from each one of these. The first one is to eliminate the hazard completely. So if you're growing a crop that needs or has control that takes a pesticide that's really pretty virulent, that has a high potential for injury, one way of mitigating that is to switch pesticides to something that maybe isn't quite as bad, or better yet, just eliminate it totally. Stop growing that crop, come up with a different agronomic process or way of growing it that doesn't require that pesticide to be used anymore. But that isn't always applicable. If you say that in our company we're going to eliminate the risk of tractor overturn, well, as long as you have tractors operating, that risk is going to be present. So to say that you're going to eliminate the risk of tractor overturn, the only way you're going to do that is to eliminate tractors, and that probably isn't going to happen. So elimination isn't something that's always possible. Sometimes it is, sometimes it isn't. Substitute, this I mentioned kind of in the last one with eliminate, but maybe you can't eliminate something, but maybe you can substitute a less virulent pesticide for one that you're already using, and maybe it's just a better way of doing it. It's not quite as hazardous, still hazardous, but not as hazardous, so it moves down on the scale a little bit. By substituting one thing for another, you're reducing the risk to the workers. Next one down on here is, being an engineer, of course, one of my favorites, but come up with a method that is built in that puts a barrier, or somehow puts the operator, puts the employee, puts the worker on a different side of the hazard. It moves the hazard, separates the hazard from the person. On the left-hand side is a PTO drive that the cover's been removed from, or maybe it's an older drive and never had a cover, so it has moving parts that rotate fast. You can easily pick up a piece of clothing or hair or something else that might be coming close to it, as opposed to on this willow harvester, the drive mechanism is completely enclosed in this tube, these two tubes, and there's no part there that someone can, by mistake, lean into, get close to. There's still warning labels on it saying, hey, stay away from this, but that risk of the moving part is completely enclosed, and so the person's been removed. So that's an engineering sort of thing, a way of designing in something to keep people away from the hazard. Next one, moving toward the least effective side of things, are warning labels. Again, many times for liability reasons, but also just to inform people that, hey, there is a hazard here, a slip hazard, or an entanglement on a PTO shaft, or hearing protection ought to be used. Those labels and warning signs are important, because if someone isn't familiar with that, may not know that hazard exists, it's a way of communicating, hey, there's a hazard here, be mindful of it, or wear this particular equipment if you're going to be in this area, so that you know that you ought to be wearing hearing equipment here. But again, moving toward the less effective, because people aren't going to necessarily pay attention to the things that they ought to be paying attention to. Moving down the list, administrative controls. And this has to do with the word administrative you use in here, but managerial, somebody who says, hey, there's a hazardous area out here. People here are exposed to dust. They shouldn't be there for very long, so I'm going to rotate people through there and not have them have the risk of exposure for much time at all. So you're administratively handling the risk or mitigating the risk by somehow moving people through or somehow removing them from that area so they aren't exposed for a long period of time. Again, it's less effective because, again, people are involved, and as soon as people become involved, then it's more difficult to make things happen the way they should. Last one on the list is personal protective equipment. It's the least effective because the worker has to do it, the equipment has to be there, it has to be at hand, and then the person ultimately has to put it on and use it. And so you're relying on the person, and way back a little ways anyway, as we said, people aren't real good at carrying through with what they know they need to be doing. So PPE ends up at the bottom of the list there. Very good stuff for sure. Hard hats, gloves, eyewear, eye protection, all very important things. But again, if you can somehow handle the hazard a different way, then you don't have to worry about the person putting these things on. Another thing within the preventing and controlling of hazards and risks is being mindful of what the different regulatory and code type things that exist that apply to your operation. Again, in the manual, there's a listing of these from OSHA things that apply to agriculture, labor and industry things, EPA, environmental protection agencies, building code, fire code, sorts of things that apply, and some of the ones that might apply to your operation. You should know what they are, because obviously you're responsible for that, and should know what those different things are. So now we've talked some about the hazards and the risks and maybe how you can identify and mitigate those. Let's move into how might we train employees. What are some of the different methods that exist for training employees? And not only is this important just to have people trained, but also it's important because sometimes if you are a regulated company, you need to provide documentation of training, whether on an annual or some sort of regular basis for those operations. There is a difference between education and training. Education is oftentimes just looking at the concepts, the principles. If you're talking about fire, maybe it would be learning the fire triangle that exists for what a fire needs to actually burn. And if you come down here to training, that's trying to put that education into practice. And it's the practical application of the information presented. So here, someone's learning how to use a fire extinguisher, and maybe up in the education part, they learned about the fire triangle, and down here, they're learning if they remove the oxygen, then the fire will go away. So education and training are two different things, And training is generally within a company what is really needed so that employees know what it is they're supposed to be doing and how to perform a job in a safe way. Within this section, there are a few different ways looked at of how you can do the training. One is something called Job Safety Analysis, or JSA for short. And the manual explains how you go down through and you select the job that you want to take a look at. You break the job into steps. How many steps make sense? And then along the line of each one of those steps, you're identifying potential hazards. And then fourth part is to how do you handle those potential hazards? What are the solutions for those things, and what are the actions that are needed then to carry those out? So this is just taking a look at mowing a switchgrass field with self-propelled mower and what this might look like. So there's a listing on the left of the basic job steps. One of them, check your drive to the field to be mowed. So think about, how you're going to get there. Crashes with motor vehicles on the roadways. That's a potential hazard. So what are the things that maybe you can do to mitigate those hazards? Well, make sure your SMV is in good condition. You have your ROPS and seatbelt in place. Are the brakes working? If you're towing something, is it in road configuration? Those kinds of things. So the JSA can be done for a very simple thing, changing the wheel on a grinder or changing a headlight. It can be done for any number of things, or it can be done for larger operations as shown here. But it helps somebody new to that job understand what needs to be done, how it's to be done, and why it's to be done the way it is, and what things you need to keep an eye on to make sure you're conforming. Another way of getting information across is through tailgate training. Just short, small group type things, usually either led by workers or supervisors on a regular basis, times allowed for questions, and tailgate training oftentimes is also a good place to talk about close calls. And that's the kind of safety culture that you want to be really developing within a company, is that workers aren't afraid to come forward and say, hey, I just about got hit by this. What can we do so that doesn't happen again or happen to somebody else? And that's where tailgate training, small groups are a good place for that sort of thing. And those things can be discussed, and then those solutions can be brought up to supervisors and to management level folks to actually implement. And then finally, the last section is about evaluating, because obviously if you're training, you want to know whether or not your training is being effective. And training can be formal or informal. Or evaluation can be formal or informal. Oftentimes, informal evaluation is just after the end of a presentation, just asking somebody to do what they've been asked to, whether it's how do you hitch up a wagon to a tractor, and just making sure they understood the steps were making sure they understood the different steps and how and why they were there to be doing it the way they're being asked to do it. Or it can be more formal, where they fill something out and that's then filed away. And then over time, sometimes the formal way of evaluation is the one that has a better record of being done. So it's a good idea to kind of combine both of them, so that there is a record of evaluation, that your training program is something that's documented, that these people have been through this training, and every year they've done it. And these were the suggestions for improvements. This is the way we improved it. And yeah, we are on a continuously evaluating our training and making it better, more applicable to our situation. So that's the information that's contained in this manual. Obviously, these have just been a few bits and pieces, but might give you an idea of the sorts of things that are in there. It's more than just making sure the guards are in place, or that you chock the wheels on the wagon when you park it. There's more to it than that. There's this whole idea of a continuously running program that begins with the safety policy and saying this is what we're going to do, and then carrying that policy out by determining what the hazards are and continuously trying to reduce those hazards or eliminate the hazards, and different ways of looking at how you can do that. So right now that publication has just moved across the street again to the Ag Publications Department here at Penn State. It should be out fairly soon. It'll be listed in the agricultural publications through Penn State, and If you order a printed copy, that'll cost a small amount, usually about $15 or so. And then the PDF of it would also be downloadable. And because this has been sponsored through the New Bio Project and other USDA grant-funded programs, there's also a downloadable PDF that would be available for no dollars, for free. And that's really what I was going to present today, kind of an overview of this manual. I'd be more than happy to entertain them.
Thank you so much, Doug. Yeah, please type your questions into the chat pod and I will read them off to Doug. We can have a discussion. Feel free, we have a small group today, so feel free to relate specific experience of yours to give context for your questions if you would like. I want to, in the meantime, while you're thinking over questions, I want to let you know that as soon as that publication becomes available, we'll make sure that it's available on the New Bio website and through Penn State Extension as well. There will also be a recording of this webinar available on those websites as well. If you would like to share this material with someone else that you know who would be interested in it. I know that it's a really busy time of year for people who are working, especially in the agricultural setting with biomass. It's a lot of harvesting going on right now, so sometimes people can't attend the live session, but we will have the recording available. So please shoot off your questions now. Doug, I guess to get us started, it seems like, you know, a lot of what you talked about with developing a safety culture and using a lot of those tools really span a lot of different industries and are not very specific to biomass. But do you want to talk over some of what you see as the highlights for specific hazards that should be considered, you know, by name as items in a safety plan for, say, you know, a switchgrass farming operation or a pellet plant or a willow situation? Any specific examples that you came across in your research that you were maybe surprised by that we should really keep in mind in this industry?
I think I don't know, is there any surprises so much as realizing that they do exist, and I think Dan's on here now, but in looking at any of these biomass crops, most of them are, or at least the grass crops, are harvested as very dry materials, and so they're grown and then they're most of the time dried down in the field, which isn't real common for usual commodity crops. They may be dried somewhat, but not to the point that these crops are. And so a couple things come into play. One is the fire hazard is real, is both out when it's growing or drying down out in the field, but also as it's being hauled and pelletized or processed somehow within the mill. And again, because it's a dry product, the fire hazard is higher, but also the respiratory things also may be of higher concern than other agricultural products are, where these small particles are airborne and can be carried a long ways, and also just are present then in the workplace. So I think those two things, the fire hazard and the respiratory hazard, you know, not just unique to biomass, but I'm not sure that they've been thought about as thoroughly as they need to be, as they have been maybe in the wood products industry, more of a mature industry.
And in your
the one thing that is a
sorry, go ahead.
The one thing, when you ask about the one thing that seems to be different, I think sometimes the one thing that seems to be different is the ability to get equipment into the field to harvest, because this is done a lot of times in the late fall, during the winter or the spring. And that's not common for typical agricultural crops. And I think that's one of the things, just the stress and the added realization that it's going to take more to get the crop out of the field realized is one thing that's going to be different about these crops.
Yeah, and we talk a lot about, you know, planting these perennial crops on marginal lands that may be marginal for a number of reasons, because they retain a lot of moisture, because they have steep slopes or are rocky, or I would imagine that a lot of those conditions would exacerbate, especially a lot of the infield operations like tractor rollover risk and things like that as well.
Yeah, I think you're correct in that, and not just the actual rollovers and whatnot, but also just the frustration level that sometimes farmers are going to get to when the crop is there and they just can't get it out, and when they finally can, feeling like they're very pressed for time and maybe not doing everything they should do to be the safest way they could be.
So in your visits, I understand that you did some site visits to biomass operations currently in practice around the state to gain some of this knowledge and experience. Did you come across any really innovative solutions to what you see as the primary hazards, fire risk and dust and so forth?
I don't know if they're innovative. I think it's, in many cases, it's people who are farmers who are beginning to get into the biomass industry, and so it's kind of a changing from a farming perspective to a industrial perspective, where in industry the fire and the respiratory risks have been there and hazards are recognized, and there are solutions for those. And sometimes I think it's the realization that, hey, these things are real and we do need to be paying more attention to them and drawing from those industrial already exist.
So if we think kind of beyond fostering a culture of safety within a workplace to the broader implications that a farmer or someone who's in charge of operating an agricultural operation related to biomass is responsible for, has liability insurance caught up? I mean, certainly there are a lot of things that you're talking about that may be more emphasized or more specific to the biomass industry, especially as we talk about these perennial crops. From the sort of official side of things, are there plans in place through major insurance carriers to recognize a lot of these risks and hazards and kind of keep up with what's new in terms of the new crops that we're seeing?
Well, I'll answer that to the best of my ability. The insurance company in general is going to be looking at a processing facility as a processing facility, and they're not much going to care whether it's biomass, perennial grasses, or wood chips, or whatever. They're going to have their requirements for what sort of safety management plans need to be in place for them to insure it. As far as people who are growing biomass crops, I'm not sure that any differences in that have been documented well enough to have made it onto the radar screens of insurance companies as a general kind of insuring the farm biomass crops as opposed to commodity crops. I don't know.
Because they are in low numbers at this point, or because they're being categorized as sort of more traditional injuries or more traditional incidents?
I think both. There aren't that many acres out there. There are some for sure, but not as many, obviously, as corn or soybeans or something along those lines. So I think numbers aren't there. And also, one of the things that we looked at back when we started the New Bio project was how injuries are actually collected and categorized. Right now, there is no category for biomass injuries or biomass crops. So if someone is growing switchgrass, that would be placed under hay growing or grass crops. So it wouldn't show up as a biomass injury, it would show up as an agricultural grass.
So let's think about some of these operations. Certainly in a small operation, it's easy to get everyone physically around a table to write out one of these safety plans, the step one of what you talked about. In a larger operation, would you draft separate safety plans for sort of each stage of handling? So would there be a tractor operator or equipment operator safety sheet? Would there be a separate safety plan for handling and movement of material around an operation, and then a separate sheet for the processing facility? Or would that, and then would those come together under some larger umbrella? How would you sort of break that down so that everyone's voice is heard in a comprehensive plan?
I'd say no to your initial question. I think I believe there should just be one safety policy for an entire company. And that policy should be the policy. There shouldn't be a separate policy within each operational area. Then within a safety committee, there may be a section from each one of the major operating, or a person from a supervisor perhaps from each one of the areas of the company, whether it's harvesting, growing, processing, transporting, processing, and whatnot. But each one should be at the table, but it should be a company policy, and it should be the company that's there. It shouldn't be broken down into little pockets here and there.
I see. And then the sort of comprehensive assessment of risk would happen specific to each category of the operation, following an umbrella policy that is written that hopefully represents everyone.
I think each company is going to have to come up with their own way of doing things, because everybody's got their own style of management. But it just needs to be inclusive. It has to make sure that it includes people from who are working out on the floor, and then all the way through the managerial, supervisory capacities of the company.
All right, we have time for a couple more questions. I see that a few of you have been typing into the chat pod. I guess in the meantime, while others are typing their questions, Doug, is there anything that you want to leave us with today that you really want us to take away from this discussion?
I really want you to take away. I guess my biggest thing that I've learned throughout this is, and this comes from visiting places like Ernst and others, but just that those companies that are one way or another, either because they're required to by insurance or because they just believe it's a good idea, or both, truly are able to kind of get this safety culture idea going. Because, and they're the ones that when you look at the safety there, people are not, they don't just scoff at wearing something. They understand why they're supposed to put on their hearing protection, or they understand why they're supposed to do something, and then they do it to the best of their ability to operate in a safe way. And I think that's in contrast to sometimes farms that don't have the training, don't have access to the training, and just haven't operated that way in the past. And it's very difficult to get someone to change what they've always done to necessarily operate in a safer way. So I guess what I'm getting at is that somehow this has to get in there, whether it's through insurance companies requiring safety and health management planning as a condition of being insured. Now, that is one way of doing it, but the better way would be for people to realize, either coming up through school, having that education that actually includes this idea, so that as they come into a system, they bring that with them and say, hey, there's another way of doing this. Why are we just forcing people to do these things without really having a group together that is running safety as an integral part of the business?
Well said. I also really like the idea that you presented of the tailgate discussions, because so much happens in these small groups in operations that have a sort of a standard crew of people working on the same problems together, and having it be a specific thing that is brought up at regular intervals for meetings makes it as much a bottom-up kind of approach where you see it in practice every day. You have these kind of regular discussions around it. It's not something that's being enforced administratively. It seems like that would go a long way to keeping the safety planning current and keeping people's eyes open about potential hazards all the time.